Hello and welcome to the 11th daily challenge. Let's get started with today's question. All right. Leetcode question 57, insert interval. You're given an array of non-overlapping intervals where interval I is the intervals from start to end. Represent the start and the end of ith interval, and intervals is sorted in ascending order by start. So it seems to me like this intervals list is sorted by the interval start. Is sorted in ascending order by start. You're also given an interval, new interval, start from end, that represents the start and end of another interval. Insert the new interval into intervals such as intervals is still sorted in ascending order by start. Intervals still by start, and interval still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals and the insertion. After the insertion. Okay, so this intervals list has two properties. The first property is that the intervals within that list are non-overlapping, means that the start and the end never overlap with another start and end within the intervals list. And an additional property is that they are sorted by the start of each interval, so in ascending order. And what we have to preserve those two properties when inserting the new interval into this list. So I'm thinking probably the way to go about this would be to start by seeing if we can easily preserve one of these two characteristics of this list. The easiest one to preserve is obviously that the new interval has to be sorted by start. So if we insert this new interval into intervals at the correct index, we will be preserving one of those two characteristics. And once we do that, I'm thinking of running some sort of merge function or join function on intervals that do overlap. And so if we were to do that, we would probably need an additional two functions, something like join and is overlapping, for example. So I guess let's start with the join and the is overlapping. Does overlap self interval and next interval, where we'll say that, okay, so this is since the intervals are sorted in ascending order by start, we can say that the two possibilities for interval intersection are if this is the interval and this is the, so if the end of the, let's see, this is interval and this is next interval. So if I wonder if I can just say that if end is greater than start, if interval end is greater or equal to next interval start, return true, else return false. I like these to do these little visuals with lines when something unintuitive is going on. For me, this, I could have done this in a number of ways. I could have looked at the the problem here is that what if they're the same, right? With the, or what if they're like this? Then the interval end is bigger than the interval start. But since they're ordered, is there an instance where? No, I don't think there is. Okay, we'll have to check that later. But then I also have a join interval and next interval, and here I'm going to just return the minimum and the max interval 0, next interval 0. Interval next interval 1. Okay, so now that we have these two functions that we're going to be running on all of the two next to each other intervals, let's insert this new interval into intervals, preserving the ordered by start. Okay, so and there are a number of ways that I can do this. However, like I could find the index that is in between I could find the index in between of the index of where the new interval should be placed into, and then do an insert. But there would be a lot of edge cases, like for example, if I don't find the interval, then I have to append it to the end. So a way that I find, I basically want to avoid all edge cases, and the way to avoid all edge cases would be to insert new interval into intervals, and then do a bubble sort of the new interval from the end, because new interval is really just the one element that is out of order, and bubble sort works great for that. So that's what I'm going to do. I'm going to say intervals append new interval, and then I'm going to say that I have a length intervals, and then for in range L, going to be looking at previous index. Remember that we are starting from L minus I, and L minus I minus 1, current in index L minus I, and then we're saying if intervals prod index is greater as current, index, so the condition that the previous index start is greater than the current index start, then basically switch them temp is going to be equal to previous index is going to be equal to the current index, and current index is going to be equal to temp. Just a quick switch, and let's see if we actually print these correctly. If intervals index out of range, index out of range, I probably messed something up here. This will have to be -1, this has to be -2, and since we have the sort of the next interval here, we can do this. Print intervals. Let's see if the standard out is sorted, and it seems like it is. I had the new interval 2, 5, and it started off at the end and moved into the correct position. Sweet. So now that I have this, let's do the traversal of the intervals array and join all overlapping intervals. The overlapping intervals are going to be next to each other. Potentially they are also going to be, once an interval gets joined, there's another interval next to it that can also be joined with it. So we'll have to probably keep track of 2 pointers, one pointing to the current interval and the next interval being pointed to, or another index that is pointing to the next interval. If the 2 intervals are not overlapping, then just add current interval to the answer array. However, if they are, then merge the current with the next, and do that until next is no longer intersecting. So, okay, pretty sound logic. We're going to start with this and say that while current is less than L, we'll figure out if we're doing an out of bounds here later or not, but I'm going to say, and next is equal to current plus 1, and while self does overlap intervals current and intervals next, while they do overlap, I'm going to say that intervals current is equal to actually the join of these two. Next plus equals 1, and once the current and the next are no longer intersecting or overlapping, then I'm going to say answer append intervals current, and also going to set current to next, because we no longer have to be concerned about any of the next intervals that we just compared. So the current is just going to be equal to the next. Return answer. Let's see if this is okay. So yeah, so I'm getting an index out of bounds error. The reason for that is because I'm saying that current is less than length. However, I'm also looking at the next interval. So here I'm actually going to say that if I'm already at the last interval, and the last interval didn't happen to be caught under the next index, then I'm going to say if current is equal to L minus 1, answer append intervals current. and index is still out of range. Let's break out of this. Okay. Okay, that seems to be good. Submit and see what's up. Index out of range on a test intervals and 2, 3. Okay. Index out of range. So these, these indexes out of range are always things that get me when not doing regular for loops or for loops that actually provide you the output. Keeping track of these intervals can be pretty difficult. So let's see what is happening here. If list index out of range overlap. Wait, is there a way to use this test case? 1, 5, 2, 3. Let's add this. 1, 5, 2, 3, 1. We get an index out of. Oh, a runtime error, index out of range. Print current and next. Okay. In the case that next doesn't get set, and confused. Why is this not behaving? Where am I setting current? Okay, 1 second. I am really confused about what is going on with this print statement. I should just be able to run this. It's going to tell me that everything is correct and the standard out of each of the test cases. However, if I add, can I add another test case? It was 1. Yeah, let's do our own test case, one that's not overlapping. 5, 8, something like this. Run. Okay, that worked. What about an overlapping? Oh. plus 3. I've got an overlapping. Okay, so when it overlaps, it actually, I see. So if next is equal to L minus 1, then we're just going to say break. So in the case that next reaches the end, and there's no more there's nothing, L reaches the last element, then we just have to break. Sweet. Okay. Okay, awesome. Whew, this is the solution for the day. Let's see. Let's quickly look at a couple of other solutions. Maybe ones that are faster and that are using sort of the same approach. So in range of length intervals, if new interval end is smaller than intervals I start, if new intervals end is smaller than start, then result append new interval. So this is in the case that new interval is preceding any of the intervals. Append and return result plus intervals. Okay, so they're doing something that I thought of doing before. What if, for example, we were to immediately append the rest of the intervals once the new interval has been added? That could have been done. Yeah, they're splitting this up into 3 different scenarios. The first scenario, or it's sort of like a state machine. The first state is that we're looking for a place to put the new interval into the result. And putting a interval into the result requires 2 things. For the current interval being explored to be completely less than the new interval, and for this current interval that's being explored to not overlap with any of this new interval that's being explored, to not overlap with the new interval. And when that state is happening, all that we're doing is appending intervals to our result set. So here you can see that if new interval start is bigger than intervals end, which is the case that we're just talking about, just regularly append the interval. If the new interval end is smaller than start, the current interval that's being explored start, then append the new interval. So this is covering the case that we now have to insert the new interval into the result set. However, let's see, what is the last case? The last case is that neither one of these conditions meet, and we are forced to join the new interval. And that's what we do here. We join interval into new intervals, updating the value that we will then be exploring. Okay, I see. Yeah, so this also works, just a little bit less intuitive. And yep, see, another state machine, they have a inserted value, and then based on what it's set to, either true or false, they perform other tasks. Also was done here, just a little bit more hidden, because the state was sort of covered in this new interval parameter. Regardless, I think that this approach is still valid. Our approach is still valid, unless, of course, they really wanted us to implement a state machine, which I doubt. So, okay, thank you for watching. Some technical difficulties again are preventing me from uploading every day, but let's keep on doing the best. Okay, so thank you. See you later.